Believe it or not, I did put a screen protector. So I think it's a screen protector that you know, I've been waiting for a good excuse to get mine. I had this iPad since. No, I got it right before I came to NJ because I wanted to use it for teaching. Yeah. So I got it around maybe seven years ago. Yeah. So actually quite long already. Okay. No, I cannot remember how much it cost. Okay, let's look at elements. So far we've learned that elements can be arranged in groups and periods. So let's do a quick test. Which element is in group 15 and period 3? Okay. What group and period is calcium in? Group 2, period 4. Can you tell me, for calcium, how many outermost electrons does it have? 4. Outermost electrons. How many outermost electrons does sulfur have? 6. How many electron shells does sulfur have? 3. How do you tell it's 3? Period 3. Okay, you see how strong you are getting? Yeah? It's really, once you get the hang of it, chemistry is really just knowing how to use the periodic table. Okay? Okay, let's do one last one. Can you tell me what's the electronic configuration of argon? Very good, okay? So look at argon. Argon has 18 protons, therefore it should have 18 electrons. So if you want to know the electronic configuration, that means how many electrons is in each shell from inside out. The innermost shell should have 2, that's a max. Second shell should have 8, that's a max. Last shell is 8, plus 2 plus 8 plus 8 is 18. Okay? The narrow is really quick at that. Okay? Actually, once you get a hang of it, you notice anything above 10, you just first 2 shells put 2 8. Yeah? Because it's simple math. Thanks for the commentary side. Yeah? So, today we do a quick recap on ions. We learned that elements can be categorized in various groups. I'm going to broadly separate them into 2 categories of groups. First one, groups 1, group 2, group 13. Then we also have elements in group 15, group 16, and group 17. Here are some examples of these elements. Let's say we look at sodium. Then let's say we look at magnesium. And then aluminium. For group 15. Now, I want you to just quickly think you practice for yourself. What is the electronic configuration of all these elements that I have just chosen? Okay, now just call some names later on. Okay, so tell me what's the electronic configuration of all the elements I've written on the whiteboard. Are you ready? Are you all quite fast at this already? No. Okay, we go by register. Okay, sodium is atomic number of 11. Who's register 11? Okay, electronic configuration. 281, okay. Agree? 281? Yeah, because 11 electrons are 2, 8, 1. Very good. Next one, magnesium. Magnesium's atomic number is 12. Who's registered 12? Good. Very good. 2, 8, 2. Aluminium is 13. Who's 13? Sarisa? 283. Okay, I mean you all see a trend here also. Because they are all in period 3, so it will be 3 electron shells, all in group 3. All in period 3, so 3 electron shells. You follow the group number. 13, you see the 3, the 2, the 1, that's how you count how many is in the outermost shell. Okay, next for group 15, 16, 17. May I get for nitrogen, Sishen? 2.5. Sorry, I totally skipped. I forgot about register number. Okay, 2.5. Next one, sulfur. Sophie? 2.8, 0.6. Okay, thank you. 2.8.6. Actually, it's not a point, it's a dot. So we tend to say as chemists 2.8.6. Okay? Yeah, but I understand it's practically a decimal place because that's how we put decimal places. But we tend to say 2.1.1. Is it? Next, chlorine. Z. For real, only a few seconds. Yeah, my iPad, it was already cracked. It was bound to crack on the front screen. Okay. Yes, Z. So what is chlorine? Very good. 2.8.7. Okay. Actually, I'm very devious. I purposely let students handle my iPad. So if we, really, I don't worry. I got it at teacher's price. So it's not 1,000. Okay, so if we look at all of these elements, this is what the electronic configuration looks like. I'd like to do a quick recap. We've learned so far that all elements want to achieve a configuration that where their electron shells are filled. Yeah, fully filled. They want to be like group 18 in fact. If you look at group 18, let's look at helium. What is helium's electronic configuration? Yeah, just a simple 2. What is neon's electronic configuration? 2? 8. Okay, yeah, 2, 8. Argon? 2, 8, and an 8. Yeah, all complete, right? If you look at their shells. We call elements in group 8 noble gases. They are like nobility. Their electron shells are totally filled. They are very rich. Yeah, they are like nobility. All of these elements here, we want to be like nobility too. And they can only be like nobility to have filled electron shells only by losing or gaining electrons. Previous lesson we left off with when do we lose electrons, when do we gain? Let's look at these 3 elements in groups 1, 2, and 13. And we look at the outermost shell. For sodium to gain a noble gas configuration, is it easier to just lose 1 electron or to gain 7 electrons? Much easier to just lose 1, right? The same logic applies for magnesium. Much easier to just lose 2 to gain this noble gas configuration, or instead of gaining 6. Easier to lose 3 instead of gaining 5. So what will the new configuration look like? The new configuration should look something like that. I have sodium, right? And the new configuration should look like 2.8 because it loses 1 electron. Let's go to magnesium. Magnesium one will look like 2.8. You notice the trend? Everyone is just trying to be the nobility in the same period. Yeah? Not in the same period, in its previous period. Neon. All of them are trying to be like neon right now. Okay? Sorry, I think it's not very clear. Can you see the purple behind Teresa? You can see? Okay. Next, for aluminium. be a, after it loses 3 electrons, 2.8. All of them have now look like mobility. There's a misconception here. Some students think that by losing 1 electron, sodium has become neon. It's not the case. Because I remember, what defines the identity of the element is the number of protons it has, not number of electrons. Sodium still has 11 protons, so it is still sodium. All it has lost is electrons. Okay? It is the way its electrons are arranged now that it looks like the noble gases, but it has not itself become a noble gas. Okay, next, if we look at nitrogen, sulfur, as well as chlorine, you'll find something a bit different. Is it easier to gain or lose electrons in this case? Much easier to gain, right? From 5, right, all I need to really do is to gain 2 more electrons to become, 3. Okay, very good, started to catch me already. 2.8, just need to gain 3. Next, if it gains 2, 2.8.8. This is the new version. Easier to just gain 1, 2.8.8, so this is chlorine. I've left out something. If atoms were to lose electrons, the charge should change. I'd like everyone to do a quick revision and think for yourself. What would the charge be for each one? This one loses 2 electrons. This one loses 3 electrons. Okay? Agree? Okay, but this is how you write it. We don't write +1, +2, +3. Instead we do this, we do a plus, don't need to do the 1. Rather than +2, it will be a 2 plus, this will be a 3 plus. So we say the number of charge. We put the number first, then we put the charge. We try to say the number of charges. Joshua, yeah, but I finished making photo, then more complete. On the flip side, if you were to gain 3 electrons, if you were to gain 2 electrons, if you were to gain 1 electron, what would the charge be? If we all agree, it will be negative, right? Because it gains a negatively charged electron. But what would the charge be? Okay, let me call people up. I need to wake some people up. Not that if I call you, you're not awake. Okay, I just want to hit everyone there. Okay, let's start. Nitrogen. What would the charge of nitrogen be? If it gains 3 electrons. You don't need to look at your periodic table. So nitrogen from 2.5, then it gains 3 electrons to be 2.8. Oh yeah, it will be a negative 3. Okay, but we write it as 3 minus. Okay? Okay, what about for sulfur? Sulfur, may I get Hongyi? Sorry?
What?
Yes, what's the charge of sulfur?
2 minus.
Very good. The charge of the sulfur ion is 2 minus. Yeah, so for 2 boys, for a girl. Amy? Chlorine? Sorry? 1 minus. Okay, very good. But actually, if it's just 1, you do not need to write the 1. It's a minus 2. Okay? So thank you. So we got all of the charges of the ions. And last but not least, what do we call ions that are positively charged? Cation ions. Okay? It is cation ions, not cations. Next one. And we call the negatively charged ones? Yeah, I'll never be able to fix this up. Okay? It's anions. Okay, you can say onions for all I care, but if you were to meet a researcher next time, or you go to another school, let's say go Hwa Chong next time to present your research, don't go and tell them that this is nitrogen onion. Don't laugh at you. Okay? Okay? So this is a summary of what we did in the previous lesson. Now if you want to take photo, you can take. And today I'll teach you a new skill to pick up. And this new skill will help simplify a lot of things. Yes?
Nitrogen is supposed to have another 8.
Yeah, the same. Then nitrogen, I suddenly use period 2. Okay, this is purely random. I wasn't thinking. I was just choosing elements that I like. Yes? Yes. Fun activity. Can you spell your name with any of the elements here? Yeah, some of you have noticed some alphabets don't exist here. There's no J. So you already cannot spell your name. Not easy to find elements that can match your name. Anyone can? I am very curious. Some people can. Anyone spell the name? Okay, you can spell your name. So how many elements you need? What is Ra? Radium. So, in other words, your name is also sodium radium. Yeah? Ra. You want to spell the name? Carrot, maybe you can. I think there was a G-A and a R-A. Is there a TH? Never. Maybe we will spell your name, Garrett. Gallium, radium, and thorium. The person who named thorium really named it after the Greek god Thor. Yeah? Hey, not the Greek god, Norse god. Einstein. Yeah, name after Einstein. You can spell. Katik, how do you spell your name?
Potassium, argon,
Potassium, argon, yeah? Thorium and?
Iodine.
Iodine and? Wow. And how you spell it?
Gold.
Gold, wait.
Wait, I see what you're trying to do.
Wait, isn't gold?
I see what you're trying to
Gold
do.
is AG leh.
Titanium.
Titanium is like
Sulfur. Titanium is like carbon.
what do you
Spell
spell?
my name, guys. A-O-B-I-K.
What? You want to get out of my class? No, right? Okay, yeah, I didn't know nonsense from you. Instead, go and find Samuel. Really don't have
Oh,
There's
shit.
S. Sulfur is S what? Yeah, sulfur is S, right? Oh, but I don't have an AM. There's an AM. Oh, Americanium, almost there, Samuel. So there's an S, there's an AM, there's a U, and there's no E. Okay. I think there's no. You want to spell Samuel? S-A-M. U-E. What EU? Yeah. Okay, I think Samuel cannot spell a name. At most spell Sam. Yes. Serve. Okay, I think everyone tried to find their name. Right, you can't. There was one here, I saw a very cute class t-shirt. The class t-shirt, right, tried to spell everyone's name using the periodic table. So literally, right, let's say it is Nara, then at the back, right, they put sodium and radium. Yeah. So that was a very cute t-shirt idea.
It worked for everyone.
They had to do nicknames for some people. Yeah. Okay, today I'm going to teach you a new skill. I'm going to teach you how to draw dot and cross diagram. Again, all these skills are not difficult. With practice, you can get really good. And as a class, you are getting really good at it. So far, I've taught you how to draw one kind of model. And honestly, that form of model, you will not find your seniors doing it because it's quite complicated to draw. For example, let's look at sodium. If I want to ask you to draw Bohr's model for sodium, can you draw? But quite tedious, right? This is what you will do first. So sodium has 281 for you. Can you tell me what is inside the nucleus for sodium? How many N? How many? Okay, so there is how many protons, how many neutrons? Thank you, 11 protons and 12, I think it's 12 neutrons. 12 neutrons. Okay, then the next thing you will do then is to draw the shells, right? So we will draw the first shell, and then after you will put X. Then the second shell, we will put A. It's very tiring, right? Okay, then the last shell, you will put a Y. Okay, this is Bohr's model. Today I'm going to teach you how to draw another model, the dot and cross model. this model is way easier to draw, and this is what a lot of your seniors draw instead. Okay, but you need to pay attention during your exam whether we're asking you for boards or for dot and cross. Dot and cross, you have an easy time. Okay, let's look at the dot and cross. If I want you to draw a dot and cross model for sodium, this is what it looks like. All you need to do is this. Number one, you just need to write sodium as a symbol. Then, you do not even need to draw the innermost shells, just focus on the outermost shell. How many electrons are there in the outermost shell? Just one. So all you need to do is just this. That's all. Simple?
How do you know how many shells are there?
Sorry?
How do you know how many shells are there?
Okay, why do you ask that question? Okay, so fair enough. You do not need to know how many inner shells there are. All you need to draw, if I ask you to draw a dot and cross diagram for an atom, is to just know how many outermost electrons there are. For example, sodium, if you look at the periodic table, group 1, it has one outermost electron. So you just put sodium and put one cross. That means to say, if I ask you to draw a dot and cross diagram for lithium, it looks exactly the same. Agree? For lithium, it's also just lithium and a cross.
So what is it called dot?
Because I only use cross, right? Okay, thanks Samuel. We call it dot and cross because it's up to you whether you want to draw a cross or you want to represent it as a dot. Okay, then Gareth asked, then why is it called dot and cross? He said I should say dot or cross, right? You will see in a while because later on, when you draw the dot and cross, you will need to use both dot and cross. So let's look at the screen right now. If I want to represent sodium, this is what it looks like. Sodium atom. Sodium, the symbol, then you just put one dot. Or a cross, up to you. Very easy, right? See how easy the seniors have? But do you notice also, for you to be able to understand how to do this, you needed to do the basics first. Right? You need to appreciate that sodium outermost shell has just one electron. You need to appreciate how to write the electronic configuration. You have actually come quite far. And therefore, once you come this far, we can start to show you simpler models. This is a very easy way of drawing it. Okay, what if I ask you to instead draw the dot and cross diagram for sodium ion? What will it look like then? Okay, sodium ion. A huge dot and then a cross on it. Okay, the reality is, the interesting thing is, if I ask you to draw a dot and cross diagram for atom like sodium, remember, sodium loses one electron, correct? So if it loses electron, what happens? You just erase it away. All you need to do is to show me the charge. That's all. Okay? If I ask you to draw the dot and cross diagram for sodium ion, the dot is gone because it loses the electron. It's that simple. If I ask you to draw the ion for magnesium, dot and cross for magnesium, the original atom of magnesium looks like that. You should draw two dots. But the dot and cross for the ion, you just need to do this. 2 plus. Because it has lost these 2 electrons to form the ions. So let's look to the screen. I recap for those of you that have lost. Here is the dot and cross diagram for sodium. If a teacher were to ask you to draw the dot and cross diagram for sodium ion, all you have to do is to remove the dot. Okay, so look at the screen. You're going to make magic occur. Okay, ready? 1, 2, 3. Okay? Yeah, okay? Only mine was blown. Okay. Okay, let's go backwards and forwards. So backwards, this is what sodium atom looks like. If I want to draw the ion version of it, just take away the dot. Because it's lost its outermost shell electron. That is the N version, the ion version. Let me give you another example. Let's look at chlorine. What would the dot and cross diagram for chlorine look like? Okay, 7 dots or 7 crosses, up to you. Okay, we look at chlorine, outermost shell, 7. So the dot and cross diagram for chlorine just looks like this. You do 1, 2, 3, 4, 5, 6, 7. Just like how you normally would, except you don't need to draw the shell anymore. You do not need to draw the inner shells anymore. It's very simple. Don't even need to tell me how many protons or neutrons there are. Very simple. But then what would the ion version of it look like? Okay, the natural instinct for you is now, let's bracket it up. What's happening? A big boy, what? How come they big boy? What, if I start calling everyone by their description, it'll be very hot. Big boy. Okay, so how would we do the dot and cross diagram for chlorine? It gains an electron, right, from 7 to 8. How do I show that it's gained 1 electron? Okay, that's why it's called dot and cross diagram. Because in order to show that it's gained 1 electron, somebody else say something. Okay, you just draw 1 dot. Okay, this dot represents that this electron came from elsewhere. It gained it, it was not of its own electron. And last but not least, I need to draw the charge. Because it gained 1 electron, its charge is negative. Okay, let's look to the screen for some movie magic. So look at chlorine here. Sorry, I have to answer Isaac's in a while. We look at the screen first. So look at the screen. This is a dot and cross diagram for chlorine. But if it gains 1 electron, then you just draw 1 dot, and then it becomes a negative. Yeah. Oh, okay. Good question. Samuel asked, actually how come for sodium, after you lost 1 electron, why don't I draw 1, 2, 3, 4, 5, 6, 7, 8 electrons on the outside? Right? Okay, but that's just not the convention. So we look at what was the original state, then we adjust from there. Yeah? So we do not need to reflect how many electrons there are in the next shell. We are just trying to show how many there is left after we take away the electrons in the outermost shell. Okay? Okay, some of you are lost, let me replay the animation. So this is the dot and cross diagram for chlorine. You observe 7 valence electrons, 7 valence electrons. But to form the ion of chlorine, it needs to gain 1 electron. So you look to the screen. We just need to draw the box. We add 1 dot over here to represent the gain electron. And we add the charge on the top right hand corner. Isaac? Right. Isaac asks, currently I do it this way. I put 7 cross and 1 dot. Up to you, if you want to instead do it this way, let's say, Isaac, you want to instead do this. You start off chlorine with dots instead, correct? Is that your question? Then after it becomes an ion, you're asking, can I instead now use the cross as the new gain electron? That's your question? So the answer is yes. It's a dot and cross diagram. Up to you whether you want to start off with dots or cross. Up to you. Personally, I prefer using cross because crosses are easier to draw. Dots are, to be very honest, if you just do a full stop as a dot using your pencil, it's not obvious to the teacher. Sometimes the teacher may not see your dot. Okay? So that's why I don't like to use dot. Instead, I just like to draw 1 dot, and that dot, I'll make sure I will color it in, make it very big dot so that the teacher can see the dot. Okay? If you get the gist of what I just explained, I would like everyone to practice, try to draw the ions for all of these elements. Okay? Where can you draw this? 3 options. If you are a digital note maker, you can do digital notes. If you have a notebook, you can do it in your notebook. If you need some space in your textbook, the best page I can find that's related is you go to page 51. Page 51 there's one blank space below, and the title for that is ions. That's a very good space for you to draw this table. Okay, so this is the activity for now. I'd like everyone to prepare this table, after which I'd like you to draw the ion, dot and cross diagram for the ion. Then I'll invite 1, 2, 3, 6 people up to do the columns on the whiteboard. Okay? I'm going to prepare the whiteboard also, but for yourself, can you begin? You also prepare your table. I'm going to help everyone out. I will draw the dot and cross diagram for the atom. Your job is to figure out what the ion version of it is. So this is my atom version of it. Lithium should have 1, sodium, dot. Hey, you tell me what is the ion version of these. So you read the question. The question will tell you, right, whether to draw a dot and cross diagram or whether to draw Bohr's model. If you like it, you can follow me. You can draw the atom version and you figure out what the ion version of it later. We will never ask you to draw a dot and cross. Yeah. Hey. Oh, finish it, yeah. This is nice. I'm just going to fill in the blanks for 1. You can figure out the rest yourself. So my what? I just want to make it a bit different. Yeah. So all of these are the ones that will lose electrons. These are the ones that will gain electrons. No need to, you could use all of them dots, all of them dots. Personally, I like to use group 1 to 13 as dots. Then all of these as crosses. That's my personal preference. You find a lot of teachers don't prefer to do this, yes?
For aluminum and chlorine, the L's like a bit here.
Oh, this is how we write L in chemistry.
But lithium is like
Like this L, why we write this way, is it?
yeah.
Because the first alphabet of any element is the capital alphabet. Yeah. So I've just done one on the whiteboard. You can figure out the rest yourself. Okay. I give you around 10 minutes to try to solve this. Yes. Yeah. So you're looking for what? S and top of my right? So to form the ion, to form an ion, so they normally needs to gain heat, right? So what I'm trying to go at the bottom, I move the arrow down, is that it has gained heat for foreign element. Then I want to plot this so that we show that it has gained heat. You must show that it's right. Alright, because it's not a velocity. Okay? Yeah, be right back. I think they are RT.
If you find this is an Easter egg.
I get really up. So much guys.
Some people prefer to take additional photos themselves. Ion subset still has its 6 electrons. But it has 8 electrons. So minus here represents because sulfur gains 2 electrons. Overall, it becomes 2 times. This is multiplied, but it gains 2 electrons. I'm going to ask you to do that. Okay, everyone just take one RE. This RE should be very, very doable if you've been following through the lessons. Sorry, it's a shade clock. Yes,
You are doing what?
All of them. I'm honored. I'm honored.
Okay, class. For those that still don't understand what I just taught, I'm going to reteach it. You pay good attention, okay? And also those that just join us. Okay, I'm going to show you an example of what I'm trying to represent here. Let's look at sodium. Everyone look at sodium. So, one way to represent sodium, as we learned just now, that is not a question I'm going to answer now. Okay. So, sodium, if you look at the periodic table, what's the electronic configuration of sodium? 2.8.1. Agree? 2.8.1. That is the configuration of sodium. How do we draw it in Bohr's model? Okay? To draw it in Bohr's model, it looks like that. Agree? The first shell should have 2 electrons. Correct? Second shell should have 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Third shell should have 1 electron. Following? I'm teaching you today an easier way to represent the same information using the dot and cross model. In the dot and cross model, all we need to show is this. We just need to write the symbol, and then we just need to show how many electrons are there in the outermost shell. So I'm just going to put a dot here. That's all. Okay? So let's try another one. We look at lithium. How many outermost electrons are there for lithium? You can tell from the groups, right? It's just 1. So we will represent lithium also in the same way. I think the challenge now comes in, what will it look like in the ion form? We say that for sodium it will lose 1 electron, correct? Okay, so we look over here. If it loses 1 electron, this is what it will look like. The first shell should still have 2 electrons. The second shell has 1, 2, 3, 4, 5, 6, 7, 8. How do we represent it in dot and cross model? All we need to do is Na. Notice that it has lost the electrons, right? So if it has lost it, then it's lost it long. It has lost its outermost electron. So I don't need to draw this dot anymore because it's gone. And then I put a plus here to show what is the overall charge of this ion. The overall charge is plus positive just 1 because it lost 1 negative ion. Every ion is negatively charged. Sorry, every electron is negatively charged. So if you lose 1, overall it becomes positive. This is how you do it for the positive ions. What about something like chlorine? So we look at chlorine. This is for those that don't understand. But for the rest of you can continue doing this table up. Okay, all good? Now let's do for something like chlorine. Okay, I'm going to do this for chlorine now. Okay, so let's look at chlorine. When we look at chlorine, chlorine's electronic configuration is 287. Right? if I were to draw it in model form, this is what it looks like. There should be 3 shells, and it goes something like that. First shell 2, second shell should have 8, third shell should have 1, 2, 3, 4, 5, 6, 7. Boleh? Boleh? How do I represent chlorine in the dot and cross form? Instead, I just do the symbol and I focus on the outermost electron. So let me do this in blue. There's 1, 2, 3, 4, 5, 6, 7. So you just do the same thing. 1, 2, 3, 4, 5, 6, 7. So we only show the outermost now. It's a very simple model. Simple, eh? We also learned how chlorine can form an ion. Chlorine forms an ion by gaining electrons. It's much easier to gain 1 electron to get a full shell. So now 2.8.8. What would this look like in the configuration? It look like that. First shell 2, second shell 8. The last shell has 8 now. So let me draw this in blue. 1, 2, 3, 4, 5, 6, 7. I need to show that it's gained 1 more electron. So I need to also show that this electron didn't come from chlorine itself. So instead, I'm going to put a dot to show that this is the foreign electron it has gained. Alright? How do I show this in the dot and cross model? It is just a simplified model. So I again focus on the outermost shell. I just do a chlorine. I will again draw all of these outermost electrons. And then I'll draw the dot. Notice what I've drawn here is exactly the same as what's on the outside, just minus the circle. Save a lot of time. Last but not least, I also need to box it up to show what's the overall charge now. We know that each electron is 1 negative charge. So what will be the charge of chlorine now on the top right hand corner? Just 1 negative. So we adopt the same method for others. For example, if you look at sulfur, sulfur has 6 valence electrons. It needs to gain 2 more to become a full outer shell. The overall charge now is 2 minus. Okay? So we adopt this method to solve the rest. I have a feeling we may not have time to go through the answers. We have 4 minutes. Xavier? Oh, okay, got it. Okay, this is your homework. I would like to go through next Thursday. Is that okay? Yeah, everything is you can do very fast.
Question 8.
Go through next week.
Next Thursday, can? Why no class? Oh, okay. Next Friday. So 1 more week. The dot and cross is not the most. Okay, dot and cross you can skip. Okay? You can just do the rest. We will not give you dot and cross in exam. Yes. Okay, question 8 also can skip. Okay, that one I haven't gone through in depth before. But the rest is quite doable very fast. Okay, let me see. I only have 3 more minutes. Next lesson is B. Okay. Is that Amy? You help me do fast, son? Okay, quickly help me fill in for group 1 to 13. Okay, then let me find one more person. Everyone else, you can check the whiteboard, the answers. Did you do anything? You do? You finished already. Okay, now we do 15 and 17. Yeah, do the openness questions. The only thing you skip is the summary crossword. Okay? I mean, if you want to do it for fun, go ahead. Yeah. Okay, all other questions you can do already right now. Yes, Kartik?